We're going to review inverse functions. You've had inverse functions in your last two courses, so this should be nothing really new to you. Basically, an inverse function is a function that undoes the original function. For a function to have an inverse, it has to be a one-to-one, meaning it has to pass the vertical line test to be a function, and to be a horizontal line test to be a one-to-one function. Now, if it is a one-to-one function, to find your inverse, remember all you do is you switch your x and your y, and then you solve the new equation for your y. Also remember that since you switched your x and your y, the domain and the range of your inverse are switched with each other compared to your original function. Also, if your original function is f of x, then your inverse is denoted as f with a little negative 1 after the f before the of x. And if you're looking at it graphically, the graphs of f of x and its inverse are just reflections over the y equals x line. To verify that you have found your correct inverse, all you do is you take your inverse, plug it into your original function, and see if it simplifies down to f. Or vice versa, taking your function and plugging it into your inverse, and if that simplifies down to x, you have a correct inverse. So let's go ahead and look at finding your inverses here. We want to know whether or not these are inverses. There's a couple ways to do that. One of them is to go ahead and switch the x and the y of the original one. And then you want to go ahead and solve that for y. So here we have our x and our y. We switch them, solve it for y. So you need to add to your 6. Then you need to go ahead and divide by 3/4, which is multiplying by 4/3. And in this case, we could also distribute through, and we get this. This is your inverse. Well, you'll notice that this being the inverse of f, that also happens to be g. Now, a second way you could have done this to see if they were inverses would be to take this right here, substitute it in for x here. When you take this whole thing and plug it in for x, if that whole expression would simplify down to x, that's another way to determine if they are inverses without actually finding the inverse like we did here. When you take a look at the one on the right, we want to go ahead and find our inverse. So we're going to have to switch our x and a y. But first of all, let's find the range and the domain of your original function. Well, the domain's not too bad because you know what's on the inside can't be negative. So that means what's on the inside, your 2x minus your 3, has to be greater than or equal to 0. Well, when you solve that for x, by adding your 3 and dividing by 2, you get your domain to be x is greater than or equal to 3/2. Your range is also fairly easy here because what root do we have, or sign do we have in front of the root? Well, it's a positive root, so that means we don't get any negatives out. So that means your range is y is greater than or equal to 0. This, having the idea of your range and your domain, will help us when we are looking for our inverse here. So to find our inverse, we're going to go ahead and switch our x and our y, solve the new equation for y by squaring both sides. Then we'll be adding our 3, multiplying by half or dividing by 2. So this is our inverse. However, keep in mind that the range and the domain switch. Since our range up here was x was greater than or equal to 0, our domain down here then has to be x is greater than or equal to 0, since the range and the domain switch. Okay, here's a theorem that talks about differentiation of inverse functions. If f is differentiable on your interval, and your derivative is positive for that whole interval, then f has an inverse function g. The function of g is differentiable, and the derivative of g is really just 1 over f prime of g of x, meaning if you want to know your derivative of g, you can get that from your original inverse function g and your derivative. So you would want to take your value of x, plug it into g, take that answer, plug it into the derivative of f, and put that underneath 1.